All right, so our focus today is on generating two numerical patterns. All right, so I can generate two numerical patterns using two given rules. By the end of this week, we'll be able to do all of the things in here, but today our focus is just on generating two numerical patterns. All right. If you would write the I can statement in your interactive notebooks with the date. And today is Monday, September, 14, 2020. All right. I can generate two numerical patterns using two given rules. We're going to go over these vocabulary in a moment. So the vocabulary we're going over is numerical patterns, corresponding terms, ordered pair, and coordinate plane. So let's start off with going from known to unknown. All right, so ordered pair. Remember that when we talked about ordered pair, we said that they are two numbers and that they go in a particular order, which would be the X and the Y, and a pair means two. All right, so when I'm looking here, I want to read every single definition and see which one matches the ordered pair. First one says, a set of two numbers that define a point on a coordinate plane, rules that can be applied to get future numbers in a sequence, a grid showing the X and Y coordinates of ordered pairs, numbers appearing in the same location in different sets. So ordered pairs, I know that the ordered pair is also a point, is a set of numbers. Excuse me. I'm going to drag that right here and place it right here. So ordered pairs is a set of two numbers that define a point on a coordinate plane. And we know that the coordinate plane is that grid, looks like your graph paper, and it shows you the X coordinate and the Y coordinate as well. So I'm going to go ahead and drag that and place it here. Please make sure that you are writing down this vocabulary. And there you go. Now give us one moment to write our vocabulary. All right, so the numerical patterns. Numerical, if I do a word search for numerical, I can see here numbers. All right, and we've talked about that before when we talked about numerical data. And a pattern is, it's almost like what you notice. So a pattern would be like what I notice about the numbers. All right, it's going in a particular order. So the numerical pattern, I've got two definitions here. The first one says rules that can be applied to get future numbers in a sequence, and then numbers appearing in the same location in different sets. Pull this up here. So in the numerical pattern, which is what we're going to go over shortly, what I'm noticing is a pattern that follows certain rules. And so if I notice, like for instance, here it says add 6 to get to the next term for my x, it means I'm starting off with 0 and I'm going to add 6 here. And my next number would be plus 6, which would make this 12. My next number after that would be plus 6, which would make it 18. The rule down here, add 3 to get to the next term. So I'm starting off with 0. My next number, I'm following this directions over here. I'm noticing the pattern. I'm going to add 3. And so that's 0 plus 3 would give me 3. 0 plus 3 plus 3 will give me 6, and then 6 plus 3 will give me 9. So going back up here, that's what the pattern is. So the pattern is like the rules that apply that help me to figure out like a future a number in a particular sequence. So I'm observing that sequence. I'll give us one moment to finish up with that. All right, so back here, it says that directions here, remember that our focus for today is to be able to generate 2 numerical patterns using a given rule. So the rule here says, the direction says, fill in each table according to the rules. And so rule 1, x add 6 to the next term, y add 3 to the next term. So here is x starting at 0. What I'm going to keep on doing here is I'm going to add 6. And then 6 plus 6 to my next term would be 12. 12 plus 6 to my next term would be 18. All right, for the y, the rule says add 3 to get to the next term. It's starting at 0, so all I'm doing is adding 3 to the previous number. So I'll add 3 to here, and that's going to give me 3. And then I'm going to add 3 to my previous number. It'll give me 6. Then I'm going to go ahead and add 3 to my previous number, and it would give me 9. All right, so what I did was I generated or I created 2 numerical patterns. Here are my numerical patterns. All right, using 2 given rules. And here were my rules right here. So over here, I'm going to show you exactly how this works on our coordinate plane as well. So not only are we going to generate 2 numerical patterns and ordered pairs, we're also going to go ahead and plot them. All right, so our first says, well, let me go ahead and read the directions first. Directions, continue the pattern to find the next ordered pair. So here are the list of the ordered pairs. Remember, it's always your x before the y. This is my origin right here. And this is my x-axis into the house. So my origin is my start. That's my door. I'm going into the house, x-axis, and then before I go up the stairs, y-axis. These ordered pairs right here are also the points. They tell me the exact location on this coordinate grid, all right, on the coordinate plane right here. So all the numbers that appear first are my X coordinates, and then these are my Y's, the next ones. 5, 0 means I'm going 5 spaces on my X, and I'm not going anywhere. I'm going 0 spaces on my Y. So I'm going 5 to the right and 0 upwards. 7, 2 means I'm going to count 7 starting from my origin. 1, 2, 3, 4, 5, 6, 7. And then I'm going up 2. You know, from here, I'm going to climb up to 1, 2. And that's where the point is for that ordered pair. 9, 2, I have to count 9, and then I'm going to go up 4. All right. So always remember that you're always starting from the X before the Y. X before the Y. We're going in the house and up the stairs. So let's go ahead and plot this. 5, 0. Here is my 5. I'm going to count 5. 1, 2, 3, 4, 5. And I'm going 0 upwards, which means I'm not going anywhere. And so I'm going to grab this and then plot it right here. There we go. And that's my 5, 0. 7, 2. So I'm going to count 7 starting from the origin. 1, 2, 3, 4, 5, 6, 7. And I'm going to go up 2 on my y-axis. 1, 2. And that's at the point right here. So this ordered pair point would be right here. I'm gonna move it a little. There we go. The next one is 9, 4. So I'm going to count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going up 4. 1, 2, 3, 4. And that's 4 on the y-axis. All right. 9 on the X and 4 on the Y. I'm going to grab this ordered pair right here with a point. I'm going to bring it to its exact correct location. Now there's something that I need to notice, that there is a pattern right here. And the pattern I'm noticing is it's adding 2 on the x-axis, because this is 5 plus 2, 7 plus 2, 9. So it's going up by 2s on the x-axis. On the y-axis, I've got 0 plus 2, 2 plus 2, 4. It's also doing the same thing on the x-axis. So I can create an ordered pair based on the pattern. I'm noticing the pattern, I'm noticing the rule. So the rule for the X is add 2 based on what I see and what I observed. And on the y-axis, it's also add 2. So I can use this pattern to generate and create our missing number. To do that, I'm going to go ahead and add 2 to my x-axis and add 2 to my y-axis. It's not always that the x and y add up in the same number. So sometimes it might be add 5 here and add 1 here. It can be add 4 and add 8. However, for this particular one, it happens to be add 2 on both. And so 2 plus 9 would be 11 for my x-axis, and I'm going to go ahead and put it here. And then 2 plus 4 would be 6 for my y-axis. And notice how I was able to go ahead and generate that ordered pair just based on the pattern. If I did have a point and I was asked to plot it on the graph, I can go ahead and plot it on the graph. So I would count 11 on the x-axis in the house, and then 6 on the y-axis up the stairs, and it'll be right here. And so that's it for today. And now we know how to generate two numerical patterns using two given rules. Do we have any questions?